In this lesson, we are going to show each step on solving equations. And the first one, I noticed that there is a minus sign in front of the x plus 3 right here. So that means that I'm going to flip, because this means it's in the bottom. So I'm going to flip it to the top. And when I flip it to the top, it becomes a negative x and a negative 3. So I'm going to flip those over. And I also see on the other side that I have a minus x here, so I'm going to flip it so it becomes plus a negative x there. So I have the 3x plus 5. Now I'm going to make that a plus a negative x plus 4. So that was the first thing I do. And then the second thing I do is I combine like terms. So if I have this 3x here and I have a negative x, that means that there's a zero pair. So I'm going to be left with 2 x's when I take away the zero pair. And then I also notice that I have 5 tiles here and 4 tiles here, so that makes 9 tiles. So I'm left with 2x plus 9 on the left, and I still have this negative x plus negative 3 on the right. So if I have x's on both sides, I need to get them on one side. So I'm going to choose to get rid of this negative x on this side, so that's a red tile, so I would add a positive x to make a zero pair. Whatever I do to one side, I have to do to the other. So I'm going to add x to both sides, and that will give me 3 x's on this side, plus the 9. And on this side I have this zero pair. Right here is a zero pair, so I'm only left with negative 3 tiles on the other side. From here, I want to isolate the x, so that means I have to get rid of the 9 tiles on this side. So that means I would take away 9 tiles, which means also adding a negative 9 to both sides. So I would have negative 9 tiles on this side and negative 9 tiles on this side to make 0 pairs. So I have 3 x's still, but these 9 and the negative 9 make a 0 pair, so those go away. And on this side, I have negative 12 tiles. And the last thing I need to do is, since I have 3 x's, I only want to know what 1 x is, I divide it into 3 groups. So the math I show is divide by 3 on both sides, and that leaves me with each x equaling negative 4 tiles. For number 6, I again notice that I have a minus sign here, so that means that all of this is in the bottom on an algebra tile equation mat. So I'm going to flip all of these to be the opposite on top. So I didn't touch the 5x, but this becomes a plus, and when I flip these, I get negative 3x and negative 2 on the top of my equation mat. And there's nothing to do over here with this 4x minus 12, so I'm just going to copy that down. The next thing I do is look for 0 pairs. So if I have 5 positives and 3 negatives, 3 of those will go away, and I am left with 2 x's plus negative 2. And over here I have 4 x's and plus a negative 12 when I flip it to the top, which I suppose I should have done at the first step. So now I have x's on both sides, which means I want to get rid of my x's. So I could either get rid of these 4 x's, or I could get rid of the 2 x's. So since I like to keep things positive, I'm going to get rid of these 2x's, so I take 2x's away from both sides. The way I show that is I'm taking away 2x's from both sides. And now I am left with negative 2 here because the 2x minus 2x is gone. And over here I'm left with 2x's plus negative 12. And remember, my objective is to get the x all by itself, so that means I need to get rid of this minus or negative 12, so I need to put 12 positive tiles here to make the zero pair. So that means I have to put 12 positive tiles on the other side as well. So I'm going to show that by putting plus 12 on both sides. So I have a negative 2 and a positive 12. So I have 2 red tiles and 12 blue tiles. That will leave me with a total of 10 blue tiles. So that's 10. And over here we have the 2x. And again, the reason I did that is to make this to become 0 pairs, so that goes away. And the last step I have to do is to separate into 2 different groups, so that means I divide both sides by 2. And that gives me my answer. 5 is equal to x. For this one, I see some minus signs, so I'm going to flip those to the top of my equation mat. So the 4x stays as it is. The 5 stays where it is. That minus 3x becomes plus a negative 3x on top. And the minus 3 becomes a plus a negative 3 on top. And on the other side, I just have negative 2, so there's nothing else to do with that. Now I'm going to think of my 0 pairs. So I have 4 blue x's and 3 red x's. That makes 3 0 pairs, and I have 1 x left over. So I have x there. And then I have 5 positive tiles and 3 negative tiles. So I take 3 of them away, and I'm left with a positive 2 tiles there. And on this side, I still have that negative 2. So to get the x all by itself, which is what I want, I would need to put on 2 negative tiles to make a 0 pair. So if I put 2 negatives here, I have to put 2 negatives on the other side as well. I show that by putting 2 negatives on both sides. And that leaves me with x on this side because that's our 0 pair, so it goes away. And on the other side, I have negative 4 tiles. So that was a little messy, but we get x equals negative 4. For number 8, I see that I have a minus sign. So I'm going to flip all of this to become on the top of my equation mat. Since it's on the bottom right now, I flip it to become to the top. So I don't touch the minus 5x or negative 5x, stays there. And the negative 1 stays there. And now I'm going to flip the x plus 2 to the top, so it becomes negative x plus negative 2. And on the other side, there's nothing to flip because they're all plus signs. All right, and now I'm going to look to combine like terms and make 0 pairs. So if you look at this being negative 5x's, so that's 5 red x's, and here's another red x because it's negative, that gives me a total of 6 red x's. So that's negative 6x. And then if I have 1 red tile and 2 more red tiles, that gives me a total of 3 red tiles, so that's plus negative 3. On the other side, I have 3 red x's and another 3 red x's because they're both negatives, so that would give me a total of 6 red x's, so that's negative 6x, and then I have that plus 2 that's still there. Now if I want to get rid of this negative 6x, I would need to put 6 positive tiles to make 0 pairs. So I want to put 6 positive x tiles on both sides. The way I show that is I add 6x to both sides. And when I do that, this makes a 0 pair, so I am just left with negative 3 on the left. And also on the right, this makes a 0 pair, so I'm just left with 2 over here. And this is when I say my brain hurts. Negative 3 can't equal 2, and when that happens, that means that there is no solution to the problem. All right, and this last one, we are going to flip everything to the top. So that means that I will have 2x plus 7 plus negative 5 when I flip that to the top. And I will have 4x plus 2 plus negative 2 when I flip that to the top. Now we look to combine like terms. So we have positive 7 tiles and negative 5 tiles, so that makes a total of 2 positives. So this side is 2x plus 2. And the other side, we're going to combine the positive 4x's and the negative 2x's, so that gives us 2x's. So now I have 2x plus 2. So now, if I remove what's common on both sides, if I remove the 2x's from both sides, which is a legal move, then I will just be left with 2 equals 2. So the way I show that is I take away 2 x's from both sides, and now I have 2 is equal to 2. And since that is always true, the answer to this question is that any number will work. And that is the end of this lesson.